Hello there. Today we are going to discuss about functions. This is a very important concept in mathematics. You can find this terminology in many of the mathematics, physics, chemistry literatures. So today we are going to understand what a function is and what it does. So function assigns the element of a set A to the element of a set B. So let's say we have a set A and we have a set B. This is set A, this is set B. So it is a rule that assigns one element of this set A to another element of this set B. So this is like a machine. You can think it like this. This is like a machine to which we give some input and then it process this input and give us some output. Let's say y, and this is our function f. Then we can write y is equal to fx. Y is a function of fx. Here y is the dependent variable and x is the independent variable. Okay, so this set from which this x comes, this set is called domain of the function and this set is called the range of the function. Now let's see an example of a function. So let's say we have f of x equals to x square plus 5x plus 2. Now if we put 2 in place of x, then we will get 2 square plus 5 into 2 plus 2, and this equals to 4 plus 10 plus 2 equal to 16, right? So here y is equal to 16 for x is equal to 2. So if we take this function f here and we take an element 2 of this set, then this will map to element 16 of this set. So this set of positive numbers can be taken as positive, or any numbers can be taken as Z. So a can be taken as integer set and b can also be taken as integer set. So this function maps integers into integers. So this is what a function is. Now let's understand a concept called graphing the function. Graphing function. So we have a, let's say, a number of function f1, f2. No, let's say not like this. We have a function f of x which is equal to y. Then we can put different value of x. Let's say x1, x2, sorry, x1, x2, x3, up to xn we can put here. And for that corresponding value, we'll get a corresponding value of y also, y1, y2, like this, yn, y3 up to yn, right? So this y1 is equal to f of x1, y2 is equal to f of x2, like y3 is equal to f of x3, and in similar way yn is equal to f of xn. Now what we can do is we can make an ordered pair of these two things, x1 y1, x2 y2, x3 y3, xn yn. Now we can plot these points in a coordinate in a 2D plane. Let's say we have this x-axis here. This is our x-axis. This is our y-axis. Okay. So the y-axis or our fx here in this y-axis. So if we take 1 in x-axis, then the corresponding y-axis value will be 1 square plus 5 plus 7. So 6 plus 5 plus 2, 7 and 1, 8. So here it will be 8, right? So this point will be there, right? So this is one point. Similarly, you can take 2 and corresponding point can be found here. So let's see how this function looks like. So instead of drawing it by hand, I would like to use an online software called GeoGebra to find how this function looks like in our 2D plane. So what you have to do is let it, yeah. So you have to take y equal to x square plus 5x plus 2. So this is going to look like this. So you can plot any of these 2D or 3D function in this website geogebra.org, and you can find how this function looks like in plane. If it is a two-dimensional, yeah, we can call this two-dimensional function. There are two variables, one independent variables and one dependent variables. And if you have two independent variables, then and one dependent variables, then you can see that in a three-dimensional space. And if you have three independent variables, then you cannot see that function in three-dimensional space. So you can see the projection of that onto a three-dimensional space. So that's it. Yeah. So this is how this function looks like. So this is called graphing the function. Now, uh, yeah. So I think this is all I want to discuss about functions. And yeah, thank you for watching. And in the next video, we'll discuss about various special type of function. Yeah, thank you for your patience.